That was right when I started my studies, but after that there were two new waves. The first of these was the emergence of the transformer architecture around 2016, and then starting in 2017, the concept of pre-training began to gain popularity. So in these past few years, things have progressed extremely quickly. I feel like I was really lucky to be able to do some work during this wave of innovation.
So your advisor is Ross, right? Professor Rust, who is also in AI and the head of AI at Apple. Yes.
Right.
So what did you learn from him?
I think one thing I really felt from him is that he provides us with an open environment. He's very open to all kinds of ideas, and that gave me a lot of resources, including the environment, to do the things I wanted to do.
Okay. So then later on in your career, you also had the chance to work closely with some brilliant people from Facebook AI research and the team over at Google Brain, like Coco Lee and Jason Weston, for example. So you were in academia and hadn't worked in industry before, while they were in industry. How do you view this process, and what did you learn from them?
I think Jason is a very problem-driven person. For example, right now, the issue he most wants to solve is dialogue. So all of his work revolves around that focus. And then Cook is different from him. Cook focuses more on general methods. He prefers to use a universal approach to solve all problems. For example, the AutoML work he did before and our recent work on ExcelNet both reflect this idea, trying to solve problems using a general framework. Basically to address all kinds of problems like this.
So he pays more attention to the learning aspect.
Yes. So actually, I think I am more influenced by Quark, mainly in how to make something, first, more general, and second, how to scale it up using greater computational power.
No. Okay, right. So let's talk about ExcelNet. Why did you decide to work on this project at the time? I remember you wrote two papers before, one on Transformer XL and the other on mixture of softmax maxes, right?
Right.
What was the relationship between these two works and you, Sonar, at the time?
Yes, I think there are two parts to this. There are two issues. One is language modeling, or what we call language modeling, and the other is pre-training. So it's like the work we did before was mainly focused on language modeling, and XLNet was essentially about pre-training. At that time, we submitted Transformer XL to ICLR, right? The results were really impressive. It achieved state-of-the-art results on all the language modeling benchmarks, but it was rejected at the time because the reviewer challenged us, asking why we were doing language modeling if it couldn't directly improve the performance of downstream tasks. So I started thinking about this issue, and now XLNet is an answer to that problem. We essentially built a bridge between language modeling and pre-training, right? Because there used to be a gap between these two things. Language modeling only has unidirectional information, so it's not necessarily effective for pre-training. Yes, exactly. That's why they proposed BERT. It was actually meant to solve this problem, but it didn't really solve it. The question is, why can language modeling be used directly? Because it's not actually based on the autoregressive language modeling approach. It's based on an autoencoding approach. Okay, right. And now XLNet answers this question. Why can language modeling be used for pre-training? It essentially unifies the two frameworks. Okay, right. So our current work is inspired by the previous approaches. It's also an extension, and we've done some framework integration. That's basically it.
Okay, so right now, within Google Brain, is this model currently being applied, or what's the situation?
It's not just Google Brain. Now many departments within Google are using it. They're all very interested in this, and many of them have already started exploring applications of this model. For example, they're considering using this to replace the existing BERT, because ours can be directly substituted without any additional cost.
Okay, so in this project, how do you and your collaborators divide the work? Generally speaking, what are each of your main responsibilities? Because I know you're the lead, right? You're definitely a key contributor. So what do the others provide? Do they give you certain resources or something else?
Jihang and I are mainly co-leads, so we are responsible for the entire experiment, the main ideas, the code, and the paper. It's all done by the two of us. The others mainly contribute in ways like helping with ideas, providing computing resources, and offering some guidance on the direction.
Right, okay. So after this, or actually during this specific period of time, you could say, while you were working hard on finishing your PhD, you also simultaneously got involved with a brand new startup company, right? It's called Recurrent AI, right?
Yeah.
So could you talk a bit about what this company does, what problems it aims to solve, and how far along it is now?
What we're doing now is AI for sales, using artificial intelligence technology to empower enterprises in the communication between their sales teams and customers. Specifically, what we do is for their phone sales or text-based sales. If it's phone sales, we first convert the calls to text, and for text-based sales, we can directly use the text. Then we perform some analysis on this data to help improve their sales conversion rates. There are mainly three scenarios where this applies. The first scenario is conducting comprehensive all-channel sales quality inspections. For example, we have large clients who may have thousands of sales representatives, and every day we perform quality checks on all of their phone sales. The second scenario is recommending sales leads. In this area, we can help them match with the best leads. The third scenario is analyzing customer profiles. And the mining industry. In this specific area, we can provide essential assistance to help these clients more effectively match their individual customers with the most appropriate and right solutions for their needs.
Okay.
Knowing their profile, you can suggest the right products or services.
So it sounds like a B2B model.
Yes, we're a business provider.
So the lead recommendation is actually lead generation, right? Do you mine from public information or from existing market activities and so on? What does that process look like?
We make list recommendations based on phone calls and their historical communication data. That is, the list already exists within these calls or text records.
Is this process currently feasible in practice?
What we have can be fully automated. That is, as long as all the calls and text data are there, we can make recommendations directly based on that content without any manual intervention. This is different from traditional methods. Traditionally, there would be people offline specifically using Excel spreadsheets to organize that information, but that approach is hard to scale and not particularly accurate. In the future, we can fully automate this process, and in terms of real-time capability, right now we update once a day. That's because the features change a lot every day, and at this scale, we've been able to observe pretty good results.
Okay.
Yes.
How is the application of your solution among your clients now? What is the current progress?
Yes, right now we have in the fields of internet, education, and finance, we have leading clients in all three sectors.
Okay, so does that mean for these internet, education, and finance clients, their scenarios involve having a large amount of data or are more suited to this kind of telesales model, right? So these kinds of clients are probably more suitable.
Yes, exactly. They have a large amount of communication data. Yes, and what we do is take this kind of data and turn it into insights that can actually generate value. Okay, right. Because I think this is the difference between labeled and unlabeled data. The data they originally have is unlabeled, right? But what we do is we now have tens of thousands of hours of annotated phone call recordings in vertical domains. And on top of that, we've also done semantic annotation of the text. It's precisely through this large volume of labeled data that we're able to truly turn it into value. Moreover, this annotated data can be transferred between different industries or even between different companies within the same industry, so it's quite scalable.
So this actually addresses an efficiency issue in sales, right? In other words, it improves efficiency and then
cut costs, save time.
Right, reducing costs and increasing efficiency. So what are the technical challenges you've encountered in this process?
I think actually the hardest part is finding a scenario where we can apply these state-of-the-art technologies. Right, so this scenario needs to meet several conditions. The first is that it must create significant value for the customer. The second is that the technology you use in this scenario must be something critical, something absolutely essential. Otherwise, even if you use state-of-the-art technology and improve by 10 points, if the customer doesn't perceive it, then it's useless. The third point is that it should be a supervised learning problem, because we encounter many customer needs that are, for example, unsupervised learning problems. At this point, we need to find a way to turn it from an unsupervised problem into a supervised learning problem. So I think the scenarios we're working on now all meet these criteria pretty well. That's why we've already applied research results like Transformer XL to our online systems. In these production environments, we've indeed achieved significant improvements, and because they meet the criteria mentioned earlier, customers can perceive the value and are willing to pay for it.
Okay.
Yes.
I understand the first 2 points pretty well. The first is that it's a real necessity, right? And the second one also has a critical impact, right? What you're doing can actually bring about substantial improvement, correct?
Yes.
But I don't quite understand the third point. Why do you emphasize turning unsupervised information into light supervision? Is it because your methods are more learning-based, or is there another reason?
I think It's like this. There are two aspects here. The first aspect is that I think for deep learning, including the whole NLP framework to achieve results. Now, it has to be done in a supervised learning scenario, because if you're just doing clustering or something like that, actually using traditional methods or using an embedding for clustering yields about the same results. Of course, the second point is that compared to the past, our current supervised learning requires fewer labels because we have this kind of unsupervised approach. Yes, right, like XLNet, which is an example of pre-training, so we can effectively reduce the labeling cost for supervised learning. Yeah, so these two things are not contradictory. That is to say, in the end, the problem still needs to be defined as a supervised learning task, whether it's classification or something like structured prediction. But ultimately, we hope to use unsupervised learning to improve this process. So one aspect is the definition of the problem, and the other is the method itself. Okay, these two are different.
When you first chose this direction, what was your reason? Because NLP has a lot of tasks, a lot of problems it can solve, right?
Right.
I mean, there are dialogues and all kinds of things, so why did you choose this field as the direction for your startup?
What we actually want to do, our ultimate vision, is to use AI to improve the efficiency of all kinds of human communication in society.
Yep.
Right, and there are many types of communication. Right now we're focusing on the communication between sales and customers within enterprise services, because I think this area, the value that can be brought by reducing costs and increasing efficiency, as well as the scenarios involved, better fit the three criteria I just mentioned.
Okay.
Right, so I think in this area, our technology can potentially create even greater value.
Okay. Your main market is China right now, correct?
Yes, that's right.
Okay. So could you tell me a bit more about your other co-founders? Because I actually know that a few of them are also from CMU as well, right? Yes.
Yes, that is exactly right. We currently have 4 partners in total. Edward, Yutao, and I were all in the very same research lab when I was an undergraduate at Tsinghua. We were all working in that same lab together back then. So that's how we met back then. Later, Edward went to CMU for his master's, and Yutao stayed at Tsinghua for his PhD. Yeah, and then we have another partner, Jeff. So now there are a few of us, and I think maybe each of us has a slightly different background and focus. For example, Yutao, he was previously a core developer, probably the most central developer of a big data analytics platform produced by Tsinghua called a Miner. That platform had millions of unique IP visits, so the traffic was huge, and the amount of data behind it was also massive, with billions of paper records. Right, so aside from his academic research abilities, he also has particularly strong engineering skills in this area. Then there's Edward. He's a serial entrepreneur and has had some entrepreneurial experience in the US before. So when it comes to products and various other aspects, he's been very helpful to us. And then there's Jeff, who is also a serial entrepreneur. Previously at another company, he created this kind of achievement, taking the company from 0 to 9 figures in revenue. He led the team to reach that goal. So now, in terms of skill sets, we're relatively well-rounded in all aspects.
Okay. So during your entrepreneurial journey, this is your first time starting a business, right? So up to now, what has been your biggest gain or takeaway?
I think the biggest learning is, I used to think that if you were really good at one particular technology, you could build a successful startup and change the world. But later I realized that's not the case. For example, your scenario needs to meet the 3 conditions I just mentioned. And when it comes to AI, another very important lesson I've learned is that for AI startups, I think there are 3 essential production factors. One is the scenario I just mentioned, another is people, and the third is data. So right now we're working hard on all 3 of these aspects. I think what's really important, and these 2 points actually illustrate the same thing, is that a key realization for me is this. Previously, I might have been absolutely focused on academic or technical pursuits, but now it's shifted to pursuing things like the entire ecosystem, everything within the company from top to bottom, including all the factors of production. I think I've really undergone a change in perspective.
But ultimately, you still have to build a product, right?
Right.
Of course, with a product, you need to solve a problem, right? So my understanding of a product is basically the problem that the customer is facing, right?
Right, the problem the customer is facing. How do you define this product? And then from a technical perspective, how do you turn this product into a definition of a problem and then use your tools to solve it?
Ideally, you can use your strengths in the process.
Yes.
So the technologies you are best at or the ones you are currently doing best at.
Right, yes.
That way, you'll be in a leading position in the competition.
And you'll have a barrier. After all, you always need some kind of barrier, right? For us, using technology as a barrier might be a good choice.
Right, exactly. So the company is still